Greetings, Intro to Chem students. This is Mrs. Lusardi with Periodic Table Lesson 3. Next couple of lessons will focus on what we call trends in the periodic table. The properties of elements on the periodic table change in a predictable way as we either go down a column of elements or across a row of elements. The first trend we're going to talk about is the size of an atom, which is typically expressed as the atomic radius, the distance from the center of the nucleus to the outermost electron, similar to the radius of a circle or sphere from the center to the outermost edge. Let's put this in presentation mode. So atomic radius is the distance from the center of the nucleus to the outermost electron. As we go down a column of elements, the elements get larger. They are larger spheres. They have a larger atomic radius. So the alkali metals get larger, the alkaline earth metals get larger, oxygen down through the rest get larger. They get smaller as you go across a period. So they start out large on the left and in general get smaller as you go across to the right. So for example, sodium in the leftmost column is larger than magnesium that is one to the right. However, sodium is smaller than the next element down in the column. Sodium is smaller than potassium. So in general, this is the general trend. There are a couple anomalies, but in general, larger going down, smaller going across. Again, here's a little bit better picture of it. Larger going down, so size increases as you go down, size decreases as you go across. Well, you might ask, well, why does that happen? Well, we talked earlier about atoms having electrons that are arranged in layers. Well, as you go down a column of elements, you are adding an additional layer of electrons. Helium has one layer, neon has two layers, argon has three layers. So since you add additional layers as you go down, it should make sense that atoms would get bigger as you go down the column from helium to neon to argon. It's like adding more stories onto a building. Across a period, the explanation is not quite as obvious. As you go across a row of elements, you are adding more protons into the middle in the nucleus and more electrons into the same layer of electrons. So here we're adding protons in the middle and we're adding electrons to the same layer. We have 2 in the outer layer, 5 in the outer layer. 5 in the outer layer, 8 in the outer layer. So as you do that, you have 10 pluses in the middle attracting 10 minuses on the outside. They're going to, pluses and minuses attract. So the more positives on the inside and negatives on the outside, the more they're going to pull in tighter together. That attractive force is a lot stronger than when you have 4 protons pulling on the total of 2 electrons in that layer. This graph shows how the atomic radius changes as you go from element number 1, hydrogen, on up. So there's a little anomaly right here. So let's start with lithium. Lithium is on the left side of the periodic table. We are going across the row to beryllium, boron, carbon, nitrogen, oxygen. I think it's fluorine. And then there's a little bit of an increase when you get to the very end. But the general trend is we are going across a row. Size is getting smaller. We're going from sodium across the row. size is getting smaller. Potassium, across the row, size is getting smaller. If you look at the peaks, lithium, sodium, potassium in the periodic table, it's actually lithium, sodium, potassium. So as we're going down that column, the radius of the atoms is getting larger. Okay, that includes the presentation part of today's lesson. There will most likely be a Google form to be completed that is associated with this. Thank you and goodbye.